Let's take a look at this medium question. It's a daily Leetcode question. It's called as alternating groups 2. There is a circle of red and blue tiles. We are given an array of integers, colors, and integer k. The color of tile I is represented by colors of I. Colors of I is 0, means that the color I is red, and when colors of I is 1, means that the tile is blue. So we will be given a value of k. By that we will know that the number of zeros and one we have to take to make the alternative groups, and we'll check that all the possibilities of combinations we can make, so that we can get an alternating color of tiles basically. So we'll return this number of alternating groups. Note that since color represents a circle, the first and last tiles are considered to be next to each other. Okay, so we will be representing a circle here. It's like this. So input is of 5 and k is of 3. So we will take tiles of 3 numbers as it's a circle. So first and last tile will be next to each other. Like this. So for constraints we have 3 to 10 to the power 5, and for colors of I is 0 to 1, and 3 to k will be 3 to colors dot length. Let's take a look at the first example here. So we are given a colors array with numbers 0, 1, 0, 1 and 0, and k is 3. So we will take a combinations of 3 here. Okay. 0 is red and 1 is blue. So now we find our combinations here. So first combination will be 0, 1, 0. Second will be 1, 0 and 1. Third will be 0, 1, 0. Okay. Now we find it in the reverse order. We can take two numbers here and one number here. So what we get 1, 0 and 0. And now we will take this number 1, 0 and 1. 1, 0, 1. And then at last we will take this number 1, 0, 0. 1, 0, 0 is already here, so we will not take that. So we got 5 combinations here. So now we check, is this combination alternative, like 0, 1 and 0 will be alternate manner. So yes, this is alternate number, this is also alternate, this is also alternate. This has repeating numbers here, 0, 0 is repeating, so we will not take this. And 1, 0, 1 is already here in second number, so we will not take this as well. So we got 3 combinations here, and we will output this. Again we will now approach this with a sliding window approach here. So our array was 0, 1, 0, 1, 0, and k was 3. So previously we were finding a combination like this 0, 1, 0, as k is 3, right? So next will be 1, 0, 1, next will be 0, 1, 0, move backwards like 1, 0 and 0, and 1, 0 and 1. From this 0, 1 is repeating in our last combination, so we will take this as separate array here, and again from the original array we were getting this, so we will now append these two arrays and get our final array. From that we will try to find our possible windows here, like this. So this will be our final array. So now we start appointing pointers here. So we point left here and right here. So the indexes will be 0, 1, 2, 3, 4, 5 and 6, and we will make a variable result here. Here we will increment the value of result when we find a possible window. So firstly we check alternative number. 0 and 1 is alternative, so we simply move our r plus plus. R will be here. Now to find a possible window we will
perform operation r minus l plus 1. This is basically to move to next window. So here r is at second index and l is at 0 index. So 2 minus 0 plus 1 is 3. So 3 is matching our k here. So this is a valid window. So we make a increment here. Now we will move our left to first index and check 1 and 0 is alternative. So I can move my r to third index here. So now we will again perform operation for our second window. R is at 3 and L is at 1. So we again get 3 here. So we will increment this value to 2. Now again we will increment our L2 here and check 0 and 1 are alternative. So what we can do, we will move our R plus plus here. So R will be at fourth place and L will be at second. So what we get 3 here again. So we'll increment this value. Now we put our L to third index and write to fifth index here. So now we are already getting repeated number here in our possible 100 window. So we will skip this window and directly move our left and right to fifth and sixth place. So L will be at fifth place and R will be at sixth place. So now again we check 0 and 1 are alternative. So we move our R to here, but here we don't have any index here. We can't take this window as well. But for example, like this 7 minus 5 plus 1. So this will be 3, but this is not possible. So what we get? We get 3 windows here. So we will output 3 here.
Now we'll take a look at the code part. We will define our result as 0, our left and right 0, int and will be colors dot length mm, 4 to int right equals to 1, right will be less than n plus like our operation n plus k minus 1. So what we'll do, and right will be r plus plus. Now we can colors right modulus n equals colors r minus 1 modulus n colors right minus 1. Now we will equal our left and right. Second condition will be if our right minus left plus 1 is equals to k, then we will increment our result and left. Right minus left plus 1 equals to our k, will simply result plus plus and left plus plus. We will here we will move to our Next uh, combination here. Here we'll return our result here. Let's try to run it. This is colors, I think. Remove these as well because we have already defined one here. On error at 8. I have not closed this. Now submit it. That's all.